You are unique and there are things you only can achieve. So, hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. Yes, my dear students, today we are going to start with lecture number 3rd based on the chapter DNF block elements under our batch Excellence Batch. As our batch name itself says, excellence. That means with our constant hard work and consistency, we can achieve and we can excel in our field. Yes? So, students, keep working hard. Start solving questions if you have not started yet. So, let us proceed over today's session with a beautiful smile. Yes, my dear students, what are the topics that we are going to cover in this particular session today? As it is lecture number 3rd, and in the previous lecture, we were doing the properties with respect to the D block elements. So today we are going to finish the properties with respect to D block elements. Then we are going to proceed towards the compounds, and at last we are going to cover the F block elements. So basically this is going to be the last lecture with respect to the D block chapter. Also there will be a practice session held for this particular chapter after this lecture. So you can solve as many as questions over there, right? So students, first of all we are going to do the properties of D block elements that were left in the previous segment, in the previous lecture. Okay, after that we are going to see the compounds with respect to the D block element, right? And then we are going to see F block element and its properties, right? So shall we start our today's topic? Okay, so the very first thing, again I'm showing you the periodic table over here, because first of all we are going to cover the properties with respect to what? D block elements. Again, I guess now this is very clear to you that D block elements starts from group number 3rd to group number 12. Yes. So do you remember I gave you means a table with respect to the oxidation state? Yes, ma'am. So first of all we are going to do the property with respect to oxidation state. With the help of higher oxidation state value, students, what we can do is we can form halides as well as oxides in the case of D block elements. They have the capacity to form halides as well as oxides. So we shall be saying that according to their oxidation state, which kind of halides are being formed with the particular elements. Now let us see over here. First of all, as I'm saying, we are going to do the topic of halides as well as oxides. So first of all we are going to do the halides. Yes, physical properties we have already done, so these are the properties that we are doing. Yes, so if I talk about the halides, students, first of all, do you remember the order, or I would say the trick with respect to D block elements? What were D block elements? I gave you a simple, very simple trick for 3D series. What was that trick? School teacher values chemistry reaction which will bring faith, confidence and comfort zone. Yes, this was the very easiest trick which I have given you with respect to 3D series. So that I am writing over here again, 3D series. Shall I write? Okay, so basically it's school, teacher, values, chemistry, mechanism which brings faith, confidence and comfort zone. Do you remember this trick? Yes. Okay, now students, when I talk about the formation of halides, basically, we shall be seeing that there will be formation of halides with respect to their oxidation state. So basically, if I talk about very first about titanium, let us start from titanium first of all. Titanium can form 3 kinds of oxide. Now, if you remember in the oxidation state, I have already told you that scandium shows +3 oxidation state, while zinc shows +2 oxidation state. Rest all the elements have a capacity to show variable oxidation state. So first of all, I shall be discussing other elements which can show variable oxidation state, and according to their variable oxidation state, that means different oxidation states, we shall be forming different compounds. So if I'm talking about titanium over here, titanium can exhibit +2, +3 and +4 oxidation state. And as you all are aware that basically we are forming halides, that means we are forming compounds with halogen. So when I talk about halogen, what is the oxidation state with respect to halogen? Now halogen can exhibit, generally they have -1 oxidation state, right? So if I talk about +2 oxidation state of titanium and halogen, as I know it's -1 oxidation state. See, titanium has the +2 oxidation state, while halogen, which I am representing by X, that can be fluorine, chlorine, bromine, iodine, right? So when I am going to make a formation of a compound, it will form TiX2, right? So basically in the case of titanium, we can see TiX2. Okay, as I've told you, it can show +3 oxidation state also. So TiX3 can be formed, as well as TiX4 compound can be seen in the case of titanium. Is it clear to you people? Great. Now when I talk about vanadium, again we can see different compounds can be formed over here. Let us write. See, it can show, sorry, it's vanadium represented by V. So it can form VX2, it can form VX3, it can form VX4, and it can form VX5. Is it clear to you people? Now let me tell you one thing. When vanadium is showing +5 oxidation state, only VF5 is formed. Only fluorine basically can form its compound with vanadium when it is in +5 oxidation state. So rest all the halogens can form VX2, it can be placed in VX3, it can be placed in VX4, but in the case of VX5 only fluorine will be seen over here. So this is a very important thing that you have to mark over here, right? You can put a circle. Now moving on to chromium. Okay, moving on to chromium. When I talk about chromium, again I have told you it can show variable oxidation state till +6, from +2 to +6. So what we can say is it can form CrX2, it can form CrX3, it can form CrX4. Similarly, it can form CrX5, CrX6. Now again, when it is showing +5 and +6 oxidation state, it shall be forming compounds only with fluorine. So CrF5 and CrF6 can be observed. Okay, in +5 and in +6 oxidation state, it will be forming compounds only with fluorine, right? Right? Okay. Shall we move further to the manganese? Now, moving on to manganese, students, what we have over here? Now, I've told you already, manganese can show variable oxidation state, right? So, over here, when I talk about manganese, now there is an exception over here. See, MnX2 can be exhibited by many. But again, MnX here, when it is forming in +3 oxidation state, it will form compound with only fluorine. Similarly, in +4 also it will form only with fluorine. And you can also see one of the compounds in manganese that it is forming MnO3F. This compound is also formed over here. Okay, right? So these are the compounds that can be seen when manganese reacts with basically halogens, right? Now moving on to iron. Okay, now moving on to iron, we can see two compounds being formed over here. One is FeX2, another one is FeX3. These are the two compounds that we can see in the case of iron. Similarly, if I talk about in the case of cobalt, we can see COX2 and we can see COX3. Again, these two are observed, but in the case of COX3, again, only fluorine has a tendency to form compound when cobalt is in +3 oxidation state, right? When I talk about nickel, when I'm talking about nickel, now it will only form one, compound, that is NiX2. Okay. Now when I'm coming to copper over here, copper, if you remember, I told you it can show +1 oxidation state, +2 oxidation state, both. So for over here, we can mention, let me take another color. Okay, it can show CuX as well as CuX2. And when I talk about zinc, as I've told you, it can show +2 oxidation state. So we shall be writing ZnX2. Is it clear to you? So these are the halides that are basically formed when the compounds react with halogen, okay? Because they have different and variable oxidation state, hence these compounds are generally formed over here. Is it clear? I want you all to write it down, or you can just mark in your NCERTs if you have with yourself. Right, students? Okay. Now we shall proceed towards the next part. As I've told you, all of these D block elements shall form halides and shall form oxides both. So we have done the halide section. Now moving on to the oxide section based upon their oxidation state. Now we shall be seeing the formation of oxides. Yes, again I'm saying this thing. If you don't remember the trick, I'm going to write it over here again so that you can write it down. Okay, this is scandium. I'm writing it again for the people who have not yet written. Okay, scandium, this is scandium. Here is, I'm writing the names of the element. Titanium, vanadium. Why I'm writing this again and again? So that you can learn it very easily. Because the more you speak, the more you'll learn. Okay, so speak with me. Okay, it's chromium, manganese, iron, cobalt, nickel, copper, and is zinc. And if you have if you have not written the trick, students, here I am writing the trick over here. You can write it down. It is school, teacher, values, chemistry, mechanism. Now extra words I am writing in bracket, that is which brings, these are the extra words, okay, which brings faith, confidence, and this is also an extra faith, confidence, and I'm writing as ND because it's nickel, so we have written with ND, okay, though it is Ni, but over here in order to make the sense, okay, and comfort zone. So if you have not written the trick yet, here is the trick to remember them. If you have not written the trick yet, here is the trick to remember them. Is it clear? Okay, shall we proceed towards the oxide section? Now when I move to oxide section, again I'm going to write all the elements again. So it is school, I'll give some space in between, okay. School, teacher, values, chemistry, mechanism, which brings faith, confidence, and comfort zone. Yes, students, these were the elements. Now let me tell you one thing. Oxygen is generally having an oxidation state of -2. Yes, there are exceptions where we have seen that in the case of superoxides, peroxides, we see the variable oxidation state, but generally it exhibits -2 oxidation state. Now while forming compounds with the oxygen, the D block elements, we shall be seeing their higher oxidation state. Now when I talk about scandium, it is present in +3 oxidation state, as I've told you before also. Scandium, you know, when present in +3 oxidation state, and oxygen, I know it is present in -2 generally. So what compound will be formed? Its charge will go on its base and its charge will go on its base, so it is Sc2O3. So basically which kind of compound is formed? It is formed Sc2O3. Is it clear? Now moving on to titanium, again it has a tendency to form +2, +3 and +4 oxidation state, right? So basically I know titanium exhibits, if it exhibits +2 oxidation state and oxygen has -2, so what will happen? It's Ti2O2, or we can say TiO. So the very first compound is TiO, in which titanium is exhibiting +2 oxidation state. Now if titanium is exhibiting +3 oxidation state, so Ti2O3 will be formed. If it is exhibiting +4 oxidation state, then it is Ti2O4 will be formed. Are you getting my point over here? In other words, you can write this Ti2O4 as TiO2. That means here titanium is present in +4 oxidation state. Is it clear? Now moving on to the next category, we have vanadium with us. Now vanadium can exhibit different oxidation state up to +5. Yes, so what kind of compounds can be formed? In +2 oxidation state, it will form VO. In +3 oxidation state, in +3 oxidation state, it will form V2O3. In +4 oxidation state, it will form VO2. In +5 oxidation state, it will form V2O5. Is it clear to you people? Right. Now moving on to chromium. Again, we are going to write the same thing. Chromium, when it forms an oxide with oxygen, in +2 oxidation state, it will form CRO. In +3, it will form Cr2O3. Here it will form Here it will form CrO2. Now it won't form any compound over here, but yes, it can show +6 oxidation state also, so it will form CrO3. Is it clear? In +5 there is no compound. In +6, yes, there is a compound, so I have written over here. Now manganese, students, if you remember, it can show +2, +3, +4, +5, +6, +7. From +2 to +7 oxidation state. So yes, we can form different compounds over here. If it forms an oxidation state of +2, it will form MnO. If it shows +3 oxidation state, it will form Mn2O3. If it forms +4 oxidation state, it is MnO2. If it forms the +5 oxidation state, it is Mn2O5. If it forms the +6 oxidation state, it is MnO3. Are you getting my point? You have to write as many as compounds here you can. Is it clear? So see, here you need to make compounds just as I've made over there. Here you just have to do this basic thing. The rest is very clear over here. It is very simple. Until and unless you're not going to write, you're not going to get what I'm saying over here. Okay. Now at last is 7 oxidation state 1, right? So it is Mn2O7. So these compounds are seen in the case of manganese. Now coming on to our iron section. Iron, iron. Okay, if I talk about Fe, that is iron, again we can see that three kinds of compounds are being formed. First is FeO. FeO is seen. Second one that you shall be seeing is Fe2O3. Now you have already seen these kinds of compounds being formed. So I guess there is no problem over here. And one is Fe3O4. So these compounds are generally seen in the case of iron. Great. Okay, now students, moving on to cobalt. If I talk about cobalt, again two kinds of oxidation compounds can be formed over here. Okay, we shall take this color. Now, first is COO. Cobalt is represented by CO, then is O. Another one is CO3O4. Right? If I now talk about nickel, only one kind of, it can be seen, that is NiO. Now, if I talk about copper, okay, if I talk about copper, again we have two kinds of compounds, that is CuO, another one is Cu2O. Okay, these are the two compounds that are seen. And last, when zinc is present, in +2 oxidation state, so it shall be forming, which color to take? ZNO. Is it clear? So these are the oxides that are generally being formed when basically all the D block elements react with oxygen. Is it clear to you, students? Now we shall proceed to the next property of ours. Let us see what is the next property. Okay, next property now comes, one second. Next property now comes out to be magnetic properties. Now students, if I talk about magnetic properties, basically there are three kinds of properties that you can be observing over here. Number first is diamagnetic, paramagnetic and ferromagnetic. Okay, so basically we can see over here diamagnetic, paramagnetic, and last is ferromagnetic. So these three magnetic properties can be observed over here. If I talk about diamagnetic, it is repelled by the magnetic field. If I talk about paramagnetic, it is attracted by the magnetic field. So we shall write the definition first. You can see, if I talk about dia 1, it is repelled. Okay, so it is repelled by magnetic field. Para 1 is attracted para 1 is attracted by magnetic field. Okay, if I talk about, in the case of diamagnetic, there is 0 unpaired electrons. Do remember this? While in the case of paramagnetic, yes, there is the presence of unpaired electrons. So over here, 0 unpaired electrons. Here there is presence of unpaired electrons. Okay, there is a presence of unpaired electron. Now, with the presence of unpaired electron, you can calculate the magnetic moment. I guess you all know the formula. Basically, we have done the formula with respect to magnetic moment in the class 11 standard also. What was the formula? Nu is equals to root n plus 2 Bohr magneton. Right? So this is the general formula in order to calculate the magnetic moment, where over here n stands for number of unpaired electrons. Great. Okay. Now students, if I talk about ferromagnetic, it is very strongly attracted by magnetic field. Right? Now ferromagnetic, ferrimagnetic, all of these terms we studied in the chapter solid state as well. So basically what is ferromagnetic? Which is very much attracted by magnetic field. By magnetic field. Kindly write it down, students. Also, you can open up your NCERT and read the segment from there. Okay, kindly write it down, students. Now, moving on to the next property, that is formation of colored compounds. Now, who will form colored compounds? The one which have unpaired electrons, they have a tendency to show or form colored compounds. Okay, so you can write over there, colored compounds. What is the basic condition? The presence of unpaired electrons. The presence of unpaired electrons. The one which have unpaired electrons, it will show color. Now, why it will show color? Because they can show DD transition. because they can show DD transition. The one in which D subshell is completely filled, they won't show any kind of transition, hence they won't have any color. So basically, the presence of unpaired electrons are responsible for imparting colors, and we can say why it happens due to the DD transition, right? Also, there, I want to state one thing. When scandium is present in +3, what happened? Okay, when scandium is present in +3 oxidation state and Zn is present in +2 oxidation state, both of them will show no color. Both of them will show no color. They won't have any color. Is it clear to you people? Is it clear to you people? So what you have to do is you have to write the electronic configuration for the particular elements that are being provided to you. Hence you have to check number of unpaired electrons. If yes, there are presence of unpaired electrons, yes, they can show DD transition. But if there is an absence of unpaired electrons, they won't show any color. They won't impart any color. Is it clear to you people? Right. Now moving on to the next topic of ours. Next topic comes out to be the catalytic properties. Now catalytic properties. Why does catalytic properties are being seen in the case of D block elements? Basically, it is due to the presence of variable oxidation state. D block elements have a tendency to show different oxidation states, which I've already told you in the previous lecture. We have made a chart with respect to that. So that's why they show catalytic property. Now you have seen various processes. For example, contact process you have seen the Born-Haber's process, right? Also, I again and again I was saying when I was talking with respect to D block elements that nickel, platinum, palladium, they have a tendency to show they are seen in the process of hydrogenation on inorganic chemistry. So why does it occur? Basically because they have variable oxidation state. That's why it shows catalytic property. Now let me read it. These are lines from the NCERT so that you can mark it over there. The transition metals and their compounds are known for their catalytic activity. This activity is described to their ability to adopt multiple oxidation states and to form complexes, because they have a tendency to form different variable oxidation states, hence it form different complexes. Great. Now vanadium oxide, they are saying that we have seen them in the contact process. Vanadium V2O5 we have seen over there, right? Finely divided iron we have seen in the Born-Haber's process. Great. And nickel in the catalytic hydrogenation. Also you can mention platinum and palladium with that, right? Are some of the examples of the catalysts that are being used from the D block elements. Is it clear people? Yes. Okay. So this was about catalytic properties, my dear students. Now moving on to the next topic, that is the formation of interstitial compounds. Now basically this is very simple. Just kindly put a heading over here first of all. Formation of interstitial compounds. See, when I talk about interstitial compounds, in order to explain you, let me tell you one thing. We have seen in the previous, lecture also, I've told you that D block elements are basically transition metals, right? Now, transition metals have a tendency to form different lattice structure, crystal lattice, and I've already told you it sometimes seems to be like this. Now, what happens, students? These are the lattice sites where basically the atoms, ions, or the molecules are kept. These are the lattice sites where they are kept. Now what happens when they are being bonded with each other? They form a crystal lattice. So I would say that there are small size elements that come and fit inside the voids. Now what are voids over here? What is this word, ma'am, you're using? This word is basically we learned in the chapter solid state. What is the void? Void is an empty space. Okay, void is an empty space when all the atoms are connected to each other. We can say that. Now over here, when these atoms are forming bonds with each other, there shall be some empty space present in between them. Now when small elements such as hydrogen, carbon, nitrogen, boron, small size one I am talking about, when they come and fit fit into the voids, they shall be forming the interstitial compounds. Now let us read over here what is they are saying according to NCERT. Interstitial compounds are those which are formed when small atoms like hydrogen, carbon, or nitrogen are trapped inside the crystal lattice of the metals. In their cases, in the metals, as D block elements are transition metals, so when these small elements trap into their empty spaces, or I would say the voids, okay, I'm writing with the word, if you don't know, it's voids, okay, into their empty space, when they get trapped over there, they will form interstitial compounds. They are usually non-stoichiometric and neither typically ionic nor covalent, right? Now we have seen non-stoichiometric and stoichiometric again in the solid state chapter. For example, now they are saying when carbon fits into titanium crystal lattice structure, it shall form TiC, Mn4N Fe3H. Basically these are the compounds that we can shall observe over there. Now again, VH 0.56, Ti titanium when forming bonds with hydrogen, basically hydrogen fits into its void, it will form a interstitial compound. 1.7, etc. The formulas quoted do not of course correspond to any normal oxidation state. They are saying the formula that we are observing over here, that is not seen commonly, okay? Because of the nature of their composition, these compounds are referred to as interstitial compounds. Great. Now see, the principal physical and chemical characteristics of these compounds are as follows. This is now important, you have to mark it in the NCERT. That's why I've written the NCERT lines over here. They have higher melting point, higher than those of the pure metals, because now they're forming interstitial compounds, right? Because there is an addition of something, small elements. Now they are very hard. Some borides approach diamond in hardness. They are so much hard. Next is they retain metallic conductivity and they are chemically inert. Now this point is also very important. Okay, so kindly mark in your NCERT. These 4 points are really very essential if I talk about the topic formation of interstitial compounds. Now moving on to the last property, students, comes out to be the formation of alloy. Moving on to the last property is the formation of alloy, or I would say the alloy formation. Now this will ends the property of D block element. What is an alloy or the formation of alloy? Basically it is a blend of two metals. When two metals blend with each other, it will form alloy. Really sorry. Now basically see what NCERT says. Alloy is a blend of metals prepared by mixing the components. Again, what I have already told you. Now why the elements show this kind of property? Because due to their similarity in size, they shall form alloys. Now see, alloy may be homogeneous solid solutions in which the atoms of one metal are distributed randomly among the atoms of the another element. Such alloys are formed by atoms with metallic radii that are within about 15% of each other. Okay, because of this similar, now this is the thing which I've already told you right now. Because of the similar radii and the other characteristics of transition metal, alloys are readily formed by these metals. Why? Due to this similarity in size. Alloys formed are hard in nature. Rest, they have high melting points. Now they have given you some of the examples which you should know, right? The best non are ferrous alloy, chromium, vanadium, tungsten, molybdenum, manganese are used for the production of variety of steels and stainless steel. Now see this one, alloys of transition elements with non-transition metals such as brass. Now brass is a combination of alloy of brass is formed from copper and zinc, where you can see the copper is present in about 80 to 90%. Why, if I talk about a zinc over here, it is present to 20 to 30%, right? And bronze, now bronze is made from copper to tin and a mixture of two metals, right? And also are of considerable industrial importance. They have certain importance also. So last lines are really very important that you have to learn from the NCERT itself. Right, my dear students, I want you all to write it down so that we can move on to our next topic now. Is it clear? Okay, let us see the next part. Now moving on to the next part, moving on to the compounds, I would say one of the things that whenever oxides are formed, like I've told you that basically D block elements have a tendency to form oxides as well. So why they have a tendency to form oxides in halides? We have seen this case because they show variable oxidation state. Also they have a tendency to form interstitial compounds due to variable oxidation state. Also why they show catalytic property? Because of the variable oxidation state. So major reason is variable oxidation state. But what question can generally be asked in the case of oxides? See, when oxides are formed and when a low oxidation compound, a low oxidation state oxide is formed, so is it acidic, is it basic, is it amphoteric? This kind of questions are generally asked. So if we say low oxidation state oxide is formed, it shall be acidic in nature. Sorry, it shall be basic in nature. When I will say high oxidation state oxide is formed, it will be acidic in nature. Okay, so low one will be basic and high oxidation state oxide will be acidic in nature. Now, when I'm talking about acidic nature, basic nature, do you remember there is a nature amphoteric nature? Yes. So when intermediate oxidation state oxide is formed, that is amphoteric in nature. I shall give you one example, you will automatically get it. When intermediate oxidation state oxide is formed, it is amphoteric in nature. Is it clear to you? Now giving you one of the examples, you will automatically get it. If I talk about, you know variable oxidation states of a certain element. If I talk about chromium, now let us see. If I am talking about CrO, the very first, in which chromium is present in +2 oxidation state. If I talk about Cr2O3, in which chromium is present in +3 oxidation state. And if I talk about CrO3, let us say, in which chromium is in +6 oxidation state. So now how you will tell? See, here it is in +2, low oxidation state. So ma'am, it will be basic in nature. Okay. If it is Cr2O3, that means it is intermediate. So ma'am, it is amphoteric in nature. And over here, chromium is present in +6 oxidation state. So ma'am, it is acidic in nature. Are you getting my point? So by this way, you can easily tell us that which kind of oxide it is. Is it clear? Now we shall move on to the compounds topic. One second. Okay, now we shall start with potassium dichromate. Now what is potassium dichromate? It is K2Cr2O7. K2Cr2O7. Now students, I want you all to open up your NCERTs because I am going to write it over here. Also you will be writing with me, but you can read NCERT along with it. So it will be helpful, it will be double benefit. You are reading it, you are understanding it, and then you are reading from NCERT, so the topic will be very clear to you. When I talk about potassium dichromate, its preparation will be made from its ore, from chromite ore. So basically potassium dichromate is made from chromite ore. Now what is chromite ore, ma'am? It is very simple. It is FeCr2O4. This is the chromite ore. You can even write it over here. This is chromite ore. And I am talking about its preparation. The preparation of potassium dichromate. It is done from chromite ore. Now what will happen? This chromite ore will further react with Na2CO3 and O2. What will happen? This FeCr2O4 will react with Na2CO3 plus O2. What will happen over here? First of all, sodium chromate will be formed. What will be formed over here? Sodium chromate. Now sodium is Na chromate. Now basically see how you have to do this. Over here you can see Na positive is there. Right? Over here what you can see? Over here see. It is Cr2O4 minus 2. Basically this is right. So when Na positive and this combines, it comes out to be Na2Cr2O4. This is sodium chromate. See, its charge will go on its base, its charge will come on its base. Basically this is the positive charge species, so it will be present over here at the left hand position, and this is the negatively charged, so written the right hand side direction. So basically this is sodium chromate. So basically this is what? This is sodium chromate. Now other than this, what other compounds can be formed? If you see over here, as you are taking Na2CO3, so yes, CO2 will be released. Also you have taken iron, so Fe2O3 will be released. Is it clear to you people? This is the first reaction, but still see, we are not getting potassium dichromate. We got sodium chromate, we have not got potassium dichromate. That means we have to further react. Now we shall react with H2SO4. The next process is we shall react. This is the first step. The second step, see the second step, what will happen? Now this Na2Cr2O4 will react with whom? Ma'am, with H2SO4. Then what will happen? What will happen? It is quite simple, ma'am. Na2SO4 will be formed. Ma'am, Na2SO4 will be formed. Yes, Na2SO4 will be formed. But what else can be formed? Now here it is sodium chromate, but now sodium dichromate will be formed. Here it is the sodium chromate that is being formed, but now sodium dichromate will form over here. Now what is sodium dichromate? What is the formula of sodium dichromate and sodium chromate? So it is Na2Cr2O7. This is sodium dichromate. This is sodium dichromate. Is it clear? Now in the next reaction we shall be getting our final product, that is potassium dichromate. How you will getting? You will react with this with KCl. Okay? Now see over here what is happening. Na2Cr2O7 with KCl. Yes, what shall we form over here? We shall be forming K2Cr2O7. Other than this, what is less? What is left over? Chlorine is left over, sodium is left over, so they both will combine forming NaCl. So yes, this is the formation of potassium dichromate. So basically, it is a three-step reaction which I have shown you over here. This is the preparation. This is the preparation. Now we shall be writing the structure, but before that, I want you all to write it down. Now, the question that can be asked on the structure of chromate as well as dichromate ion. Chromate as well as dichromate ion. What is chromate ion over here? It is CrO4. Now, can I write it over here? Right. See, here we will be writing chromate ion, and here we will be seeing the dichromate structure. Kindly write this first so that we can write it down first of all. Kindly write it down. I guess you all have written this. Yes, okay. Shall we start, students? Write it down so that we can draw the structure. Now, the structure is very simple. The structure is not at all tough. You won't find any problem over here. Okay. One more thing, students. I want you all to correct it over here. It is CrO4 minus 2. So, chromate ion is CrO4 minus 2. First of all, how to draw chromate ion? See what you have to write. Chromium in between. Now, it is O4. That means 4 oxygens are bonded. 1, 2, 3 and 4. Also, it carries with charge a negative minus 2 charge. So, overall charge will be minus 2. This is the structure for this. Now, when I talk about dichromate over here, dichromate was what? It was Cr2O7, power was minus 2. Cr2O7 power will be minus 2. Because sodium, if it has plus 1, then over here plus 1, it has minus 2, so it will be minus 2. This you can correct it over here. It is CrO4 minus 2. Great. Now, students, write it over here. Again, chromium. Basically, there are 2 chromium now. And you know, they both will be bonded with oxygen like this. How many oxygen are left? 6 are left. So, 3 oxygens over here and 3 oxygens over here. The overall charge is minus 2. So, this is the structure for chromate ion as well as for dichromate ion. Is it clear? Now, one thing I want you all to tell over here. Basically, chromate ion CrO4 minus 2 is in equilibrium with Cr2O7 minus 2. They come in equilibrium with each other. And if I talk about the color for the chromate ion and the color for the dichromate, it is yellow in color while this is orange in color. Okay, so you should also know the colors. This is yellow in color while this is orange in color. Is it clear to you people? Right? Kindly write it down, students. Now, basically, if I'm talking about, potassium dichromate, it will act as a strong oxidizing agent in acidic medium. So, certain reactions will be provided to you. You should know that it acts as a strong oxidizing agent. So, write it down. It acts as a strong oxidizing agent. A strong oxidizing agent in acidic medium. Whensoever acidic medium will be given to you, they will be acting as a strong oxidizing agent. Is it clear to you people? How? See, dichromate ion, because it is Cr2O7 minus 2. We have just seen. See, over here it is K2Cr2O7. That means Cr2O7 minus 2, right? So, if I talk about dichromate ion in acidic medium, that means in the presence of H positive. In the presence of H positive, whensoever reaction will be given you, it will liberate Cr plus 3. It will liberate chromium plus 3, right? Now, what will happen? How reactions can be seen? See, if it reacts with I negative, it will convert into I2. Okay. If it reacts with H2S, it will convert into what? Into S. Sulfur, sorry. Sulfur is present in right. If it is present in H2S, it will convert into sulfur. If it is present, if you reacted with Fe plus 2, it will change into Fe plus 3. Also, this will be formed. Also, this will be reacted. Okay. Now, these are the certain examples that you shall be observing over there. For example, I will tell you. For example, if Cr2O7 minus 2 is present in acidic medium, that means H positive is being provided. It is reacting with I negative. What it will form? First of all, it will form Cr plus 3. Also, what it will form? I2. right? So if it reacts with H2S with H positive, it will form sulfur plus Cr plus 3. If it reacts with Fe plus 2 with H positive, it will form Fe plus 3 plus Cr plus 3. Are you getting my point what I'm saying? So this I have written that whensoever it reacts, it will convert this into this into this. It will act as a strong oxidizing agent. If you want these two reactions, you can even write in the similar manner. Now you know this product will be formed along with these product. Is it clear to you people? Now this was the very first compound. Now moving on to the next compound is potassium permanganate. Let us start, but before that please kindly write it down. Till then I'll drink a glass of water. Kindly write it down. Yes students, kindly write it down. So next is potassium permanganate. So if I talk about the next one, that is potassium permanganate. I guess you all have written these reactions. You can read it from NCERT as well. Now what is potassium permanganate and how we have to see? Potassium permanganate, you have seen magnetate is KMnO4, right? So its preparation is very simple. You can prepare it in laboratory. You can prepare it simply also. But as you all know, in the previous case also we took an ore. Over here also we will be taking an ore, that is pyrolusite ore. Okay. Now what is in pyrolusite ore, with the help of which we can prepare it? With which we can prepare it? It is basically MnO2. With the help of MnO2, that is pyrolusite ore. How this reaction will take place? First of all, this MnO2 will react with KOH and O2. First of all, this MnO2 will react with KOH, will react with O2. Are you getting my point? What it will form? Magnetite ore, which is green in color. Magnet ore, right? Sorry if I've written the spelling wrong. You can check in the NCERT. Magnetite ore. Okay. Now, basically, you can see the spelling correction over there. What will be formed when it is reacting? See, over here we are getting potassium. Here we have MnO2. Now, what we will be forming? K2MnO4. But what we have to make? We have to make KMnO4. We have to make KMnO4. Here we are getting K2MnO4. That means further reaction will take place, liberating water, because oxygen is being reacting over here. Also there is hydrogen present, so liberating water. Now from this particular, which kind of ion is being, you are getting MnO4 minus 2, because potassium is in +1 oxidation state, so we are getting MnO4 minus 2, which is green in color. MnO4 minus 2, which is green in color. Now this will further react with what? With H positive. This will further react with H positive. What it shall form? It shall form now purplish color compound, which is MnO4 negative. Now over here it is MnO4 negative, which is forming purplish color. So we are getting our ion from here. So yes, we obtained our ion from here. Okay. Liberating MnO2 with the result as a byproduct. Liberating MnO2 as a byproduct. Is it clear to you? What we have done, this is a two-step reaction. We have got our ion for over here, that is MnO4 minus 1. Now you can also prepare it commercially. You can also prepare it in laboratory, right? So let me write the commercial and the laboratory reactions. See, if I talk about commercial preparation over here, MnO2 will be fusing with KOH. Okay, and it can be oxidized further with KNO3. So what we will getting directly? What I've told MnO2, because we have to take that ore, so we have taken MnO2. Now when it is fused with KOH or oxidized with KNO3, when it is fused with KOH or oxidized with air, or I would say the KNO3, what we will be getting? Again, we shall be first of all obtaining MnO4 minus 2. Now from MnO4 minus 2, now we will do electrolytic oxidation and we shall obtain MnO4 minus. This is our purplish color compound, right? This is our purplish color compound. So kindly write it down. Kindly write it down so that we can move on to the next part of ours, right? I guess you all have written. Now comes the structure session again. See, if I talk about structure, now we have seen two kinds of, ions over here. One is MnO for negative. Another one is MnO for minus 2. See, MnO for minus 2, MnO for negative. So, how they will be forming? See, this is manganese. How many oxygen? 4 oxygen. So, it will form single bond with this, double bond, double bond, double bond. Right? This is the compound formation. Again, over here, it is Mn O negative, double bond oxygen, double bond oxygen. So these are the structure for both of them. These are the structure for both of them. Okay, one more thing, students. If I talk about this and this compound, basically it is diamagnetic in nature, it is paramagnetic in nature. It will have no unpaired electrons, it will have unpaired electrons. And the one, basically, this is purplish in color and this is basically greenish in color, right? This is purplish in color. We have written in the previous reaction also, and this is green in color. This is diamagnetic, this is paramagnetic. If it is diamagnetic, it has no unpaired electrons, but yes, it has unpaired electrons. Is it clear? Is it clear? Okay. Just as we did in the previous compound, I told you that it is acting as a strong oxidizing agent. Similarly, potassium permanganate can act in acidic medium also. Now, in acidic medium, what will happen? It will change its oxidation state from Mn plus 7 to Mn plus 2. In acidic medium, it will change, Mn will change its oxidation state from plus 7 to plus 2. That means basically it is getting reduced. So if it is getting reduced, it will oxidize others. It will oxidize others. So what will happen when you will react it with certain elements? For example, if you react it with C2O4 minus 2, what will happen? It will convert it into CO2. Just as we did in the previous reaction. Okay, what will happen? They will give you reaction Mn plus 7 plus C2O for minus 2 plus H positive. So you know what is the product? Product will be Mn plus 2 plus CO2. Right? Similarly, over here, if it reacts with Fe plus 2, it will convert into Fe plus 3. It will convert into what? Into Fe plus 3. Is it clear to you? Is it clear to you all? There are further more examples. For example, it will convert nitrite into nitrate. Nitrite into nitrate. All of the reactions you can even mark in NCERTs. Now you can write the reaction. It is NO2 minus into NO3 minus. Is it clear? Is it clear to you all? Okay. This acts in acidic medium in the presence of H positive. Do remember this. Okay. Other than this, you can write it can convert S minus 2 into sulfur. Right, it can convert SO3 minus 2 into SO4 minus 2. These are the certain reactions. Again, I'm telling, when Mn plus 2 is reacting with this, it will form these two. When this is reacting with this is form these two. When this is reacting with this, it will form these two, along with what? With H positive in acidic medium. Do remember, it is taken in acidic medium. It occurs in acidic medium. Now when I talk in neutral medium, or fairly alkaline, neutral medium, you can write it over here. In neutral medium, what will happen? In acidic medium, so I have told you it will convert from which state? From plus 7 to plus 2 oxidation state. But over here in neutral medium, what you will be seeing, it is converting from plus 7 to plus 4 oxidation state. How come? In plus 7, what is the, it is MnO4 negative. Here it is present in plus 7 oxidation state. So if it reacts with I negative, it will form which state? First of all, here it will convert into IO3 negative. Also now it will convert into plus 4 oxidation state. Now when Mn converts into plus 4 oxidation state, it will form MnO2 over here. MnO2, right? This is the reaction in neutral medium that you should know. This is the reaction that occurs in neutral medium. Now there is one reaction, students, that you can be seeing which is different, which is quite different. What is that reaction? See, basically when MnO4 negative, you can put a star mark over here. When MnO4 negative reacts with Mn plus 2, this is a different reaction. This will form what? This will form a different kind of compound. For it will form MnO2 directly. Now this is the reaction that you need to remember. Okay. This is the reaction that you need to remember. Also, one more thing, students, do remember over here, if I'm talking about acidic medium, no, acidic medium here refers to as that you have to take only H positive. for that H positive, you only have to take H positive. Now in certain cases, what students does, okay, in acidic medium they will take HCl, but HCl won't be used over here in this acidic medium. Do remember this, you won't use HCl over there. Other than that, any acidic medium you can consider. Great. Now students, moving on to our next part. Next part comes out to be F block elements, our last topic. F block elements are referred to as inner transition elements. F block elements are referred to as inner transition elements. Inner transition elements. Now if I talk about F block elements, I've given you general introduction in your previous lectures as well. What these are F block elements? Now this is first inner transition element, first inner transition series, and this is your second inner transition series. Questions that are generally asked from this are basically that in which group they lie. Basically I've told you they lie over here in group number 3rd. So both of these, the F block elements lies under group number 3rd. If I talk about period, so you know that if I talk about lanthanoid and actinoid, they have mentioned you over here. It is in 6th period, it is in 7th period. It is in which period? It is in 6th period, it is in 7th period. Do remember this thing. If I talk about lanthanoid series, that comes after this lanthanum from 58. This is first inner transition series. If I talk about actinoid series, which comes after actinium, it is from 90th element. So this is second transition series. This is what? This is second transition series, if you remember them. Right, students? Kindly write it down. Kindly write it down. Now students, we shall study about them in detail. See, it is very simple topic, very easiest topic. If I talk about first of all lanthanoid series, if I talk about which series? Lanthanoid series. Now I have already told you they come under the category of, sorry for the spelling, lanthanoid. If I talk about lanthanoid series, they come under the category, both of them come under the category of group number 3rd. Now, if you should remember this thing, their general electronic configuration, which is very simple, my dear students. I will tell you a simplest trick to remember it. See, its general configuration is, as you all know, they come under the category of F block elements. That means their last electron shall enter into the F subshell. This is the definition that we talked about in P block element, in D block element, now in F block also. The last electron shall enter into that subshell. That's why they refer to its particular name. Now, over here when I'm writing general electronic configuration, it is n-2f, n-2f. Now in F subshell, you should know that 14 electrons can be filled. It will be n-1d. Now it is 0 to 1 over here, okay, and then is ns2. This is general configuration. Now, as you all know that lanthanoid series comes under the category of 6th period. So, n value over here comes out to be what? 6. That means if I have to write a general electronic configuration, it is 6 minus 2 is what? 4. So, 4f, 1 to 14. Now, 6 minus 1 is 5. So, 5d, 0 to 1 and 6 is 2. This is the configuration for lanthanoid series. So, how you have to remember? See, over here write 4f, over here write 5d, over here write 6s, like this. Okay, so first of all, fill all the electrons in 6s. 2 electrons will be present. First of all, fill 2 electrons. I am writing in all of these. I am telling you general way to remember the electronic configuration for all of them. So this will help you out. Now first, if we talk about lanthanum, it is 0, 1, 2. Do remember. That is 4f, 0, 5d, 1, 6s2. Right. Now after this, you know that from here lanthanoid series is being started from here. Now students, see, when you are starting from when you are starting from the very first element, do remember you have to start from 1 2 3 4. We do 1 2 3 4, but over here you have to do 1 3 4 5. Over here it will be 1 3 4 5, like this you have to go. Then see again 6, now 7 7, you have to repeat 7 7. Now 7 2 is 14. That means at last you have to write 14 14. Rest you can fill 8 9 10 11, like this. Okay, like this you have to fill. 1 second. It is 0 1 2 3 4 6 7. Again one thing, 8 you have to cut because we have written 7 2 times, no? See, we have written 7 2 times over here, right? So over here, now 8 you have to remove, 9 will come, right? And then 10 will come, 11 will come. Now again students, you have to write this in a particular series. Do remember this. What you have to do is 1, skip 2. Then you have 2, 3, 4, 5, 6, 7, 7, skip 8 because you have written 7 two times. 9, 10, 11, 12, and at last you have 12, 13, and you have 14. By this way, you have to do this. Kindly write it down. Kindly write it down, students. Let me check if I have not skipped one element. Cerium, PRNT, PMSM, EU, ED, EB, DY, HOER, TMYB. Okay. Yes, so one more element will come over here, no? It is also 14th. Okay. Yes. Yes. Can we write further? Okay. Now you have filled the 4f electrons. Do remember, you have to skip 8 over here. You have to skip second number over here. And if you are skipping 8 over here, you are writing 7 again. Great. Great. Is it easy? Now students, only 3 things you have to remember. Very simple. Very simple. In the very first case, over here 1 will come. Over the last 1 will come. Okay. And there is one more position at 1 will come. That is this. Rest all will have zeros, 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 zero configuration. Is it clear? Is it clear? Kindly write it down. Kindly write it down. Kindly write it down. Okay, now coming on to the oxidation state. Now we are going to do oxidation state along with the lanthanoid series itself. It can show +2 oxidation state, +3 oxidation state, +4 oxidation state. Is it clear? It can exhibit +2, +3, +4, in which +3 oxidation state is the most common oxidation state that is being observed. In which +3 oxidation state is the most common oxidation state, students, that is being observed over here. Is it clear to you all? Is it clear to you all? Yes. Now one more thing, students. This will show +2 oxidation state and this will show +2 oxidation state. Is it clear? If I talk about +4 oxidation state, see +3 is seen by everyone, almost everyone. But if I talk about now +4, this can show +4, this can show +4 also. This can show +4, this can show +4, this can show +4. These are the elements which generally exhibits +4 oxidation state. These two are the one which exhibits +2, and rest all can exhibit +3 oxidation state as well. Is it clear to you? So this was about lanthanoid series which I have told you. Now moving on to the next part, which you already know. There is no need to tell about the physical properties with respect to the lanthanoid series. Is about ionic radii. What will happen in the case of ionic radii? Ma'am, ionic radii will decrease. Why ionic radii decreases? Because the Z effective increases along the period. What is Z effective? Effective nuclear charge. Also, there is one more reason why basically this occurs. Why ionic radii is being decreased over here? This is because due to the presence of F subshell. Now, F subshell shows lanthanoid contraction. Why? Because it has poor shielding effect. So, the major reason first is that Z effective is more. Second is due to lanthanoid contraction. Due to lanthanoid contraction. Now what it is? It is poor screening of F subshell or poor shielding of F subshell. Poor shielding of F subshell. This occurs. Ionic radii will decrease. Ionic radii will decrease. Is it clear to you people? Now students, there are certain chemical reactions in your NCERT. A small chart is made with respect to chemical reactions. You have to learn that chart. It is very simple. See, when I'm talking about lanthanoid, you have to treat almost lanthanoid as aluminium. The compounds are generally similar to them, so you'll get over there. See, we represent lanthanoid as Ln. Representing lanthanoid as Ln, what I can say is when lanthanoid reacts with O2. See, when aluminium reacts with O2, it forms AlO2. Al2O3. Similarly, when lanthanoid will react, it will form Ln2O3. Very simple reactions you shall be seeing. When lanthanoid reacts with acid, it shall form H2. H2 will be released. Okay. Now, other than this, when lanthanoid reacts with halogen, that is X2, LnX2 will be formed. Sorry. Reacts with X2, LnX3 will be formed over here. When it reacts with sulfur, Ln2 S3 will be formed. Okay, these are the reactions that are already given in your NCERT. Now there is one more reaction. If you know aluminium, when it reacts with water, it forms AlOH thrice. That same happen over here. It will form LnOH thrice. Almost all reactions are quite similar with aluminium. So this is the chemical reactions chart that you can see in your NCERT, right? Is it clear, students? Is it clear? Other than this, if I talk about the general properties of lanthanoids, it is very simple, students. Lanthanoid, all compounds are basically colored except two compounds. If I talk about, all the compounds are colored. Yes. Where is lanthanoid series? Okay. So basically, if I talk about this series over here, lanthanoids, almost all compounds are colored, except if I talk about here in this particular segment, if you see all of these compounds, we shall be seeing that lanthanum in +3 oxidation state. Okay. In this, when this is present in +3 oxidation state, no, it won't be colored. Except this, everyone will be colored. Okay. Also, one more thing, students, you can say that all the compounds are paramagnetic in nature, but when there is F0 configuration and when there is F14 configuration, except this, all are paramagnetic. All are paramagnetic in nature, right, students? Great. Is it clear? Is it clear, students? Now, students, we shall be ending our session over here and we shall be doing the actinoid topic in the practice session. Before moving on to the next, in the next class, I will be bringing NCERT lines of actinoid as well, physical properties. We shall be reading it from there because there are very few points that you need to understand. Only in lanthanoid and actinoid series where you have to focus is ionic radii, the chemical reactions and the major physical properties which I have told you thoroughly with the help of oxidation state, as well as the most which I am referring over here, such as paramagnetism in nature, colored compounds, I would say. In one of the things you shall be seeing that the hardness in the case of lanthanoid depends upon the atomic number. So it is directly proportional to the atomic number. So these basicity things, this we will be reading in the next lecture, and after that we will be doing the practice session. So your homework for today is to solve your DPP that is being provided to you, okay, and also read NCERT. Right, students? Only one small topic is left that we will be covering in the next lecture. So as you all know, this is the very first day of the new year. Yes, so before ending the session, I would say, as this is the first day of the new year, so first day of the new year, it is time to shine for a new day. Your sorrow, your pain, just forget them. Your sorrow, your pain, just forget them. New ideas are awaiting ahead. It's time to recall all your memories, beautiful dreams that remain uncovered, painful part of life when your heart get crushed, but don't be afraid. The future is in your hand. Hold it in your hand. Start your race, a new journey that lead you to success. You will rise again, you will shine again. Wishing you all a very happy new year, students. It is a new year, it is a fresh page of 365 days. So start it with a beautiful smile. Always be confident, be positive in life. Yes, students, if you think that you want to achieve something in life, then only universe will help you to achieve that. But if you only will feel demotivated, then nothing will happen. Motivation can only come from within, and that power is only in your hands. So be motivated, stay positive, and always keep smiling to whatsoever situations are being given to you in life, right? So all the very best and wish you a very happy new year. We shall meet in the last lecture of the D block, D and F block elements, in which we shall be covering the actinoid series, some of the properties, and we will be doing the practice session. So I want you all to solve all the DPPs with respect to this chapter. So you can write in the comment section the doubt with respect to the DPP so that I can discuss in the practice session as well, right? So thank you so much, children. Keep smiling, keep learning. Thank you so much.